Hi, I'm David. My main job here at the BIU is to help students and researchers analyze their images. Their image dataset can be 2D or 3D. 2D means that the images can be analyzed independently from each other, whereas in a 3D dataset, those images are taken throughout the thickness of a sample and are therefore related to each other. Finally, in both 2D and 3D datasets, the number of images can range from a few dozen to thousands. Okay, now I'm going to show you a brief example about 2D image analysis.
Okay, let's start with the basic image analysis technique, that is counting the number of objects in an image. For this, I'm going to use the software called Fiji, which is open source software and very good for image analysis. And we are going to count the number of bacteria in this image. So a basic way of doing this would be to select a marker and then mark each single bacteria in the image like so, until we have all of them marked, and now we can tell that there is 21 bacteria in that image. So this technique is simple and useful if you have very few bacteria to count or very few images to analyze. But what if you have hundreds of bacteria to analyze? Doing them manually could become very much a problem. So what we could do is we could semi-automate this analysis. To do so, we can use diverse tools built into Fiji. Because most of the bacteria are darker than their background, they can be selected based on their brightness using the threshold tool. Once the bacteria are selected, the image is binarized, and this is this image that Fiji will analyze to count the bacteria. Here it is. We now have a table that will tell us the numbers of bacteria, 21. We also have a new image with an outline around each bacteria that was found and counted. This is better than counting manually. But what if you have hundreds of images to analyze? It would take a long time to get the data. So we can further automate the process by using scripts that will repeat the same analysis on many images. Here is a script I created that will do the same exact measurements that we just did. All I have to do is press Run, point to the folder where the images are located, and let the macro do its job. We can see the macro going through the images in the folder one by one, and the data is added to the summary table. At the end, the summary table is saved to the folder as well as the outlines for each image. As you can see, the whole process took only a few seconds and saved a lot of time. What if the image is in color? Then one thing we can do is split the colors and analyze them separately. For example, this image. We can separate the blue nucleus from the green fiber-like structures, resulting in 3 different windows. One for the blue nucleus, one for the green fibers, and one for the red, which looks empty because there was no red object in the original image. Now, if that's what we wanted, we could count and measure the area of the nucleus in the blue image the same way we did it for the bacteria, and even write a script that would do the work for us. This was a very quick snapshot about 2D image analysis. Much more complex analysis can be done, but there was no time to go into that because I wanted to show you some 3D example as well.
Microscope system like the Microcity, the serial block face SEM, the confocal microscope, the light sheet microscope produce 3D dataset. As I mentioned before, a 3D dataset is a collection of images throughout the thickness of a sample. Those images form a volume in which a 3D object can be extracted, viewed, and analyzed separately or in relation to each other. Let me show you how we do that.
First, the images need to be loaded into the computer to view them. Here I have loaded a CT scan of a 16 days old mouse embryo into the computer using a software called Aviso. Once loaded, the dataset can be explored from different viewpoints. We can look at it from top down or from side to side. We can recognize different organs like the heart, the lungs, the liver, the gut, etc. It is great, but it's still technically 2D. Now, what if we wanted to measure the surface area and the volume of the heart and the lung and see how these two organs relate to each other in the body of the mouse? That's where 3D comes in. So to be able to do that, the two organs need to be identified via a process called segmentation, which is a fancy term for coloring. Ideally, we would try to do that automatically using built-in tools or even artificial intelligence, but a lot of time we have to do the coloring manually, slice by slice, because the computer is not able to recognize the object we want to segment. Once we have segmented the heart and the lung, we can view them in 3D together or separately. We can also obtain their volume and surface area. It is also possible to create animations and even to 3D print them. And this is the end of this very simple and short explanation of what 3D image analysis can be.